Hello, I want to give you some practice on how to construct a random variable. Notice that we have looked at the rolling of two dice before, and when you roll two dice, this sample space, highlighted here in green, represent all the possible outcomes you will ever see. What I want to do is kind of convert that into something that might be more usable. For example, there might be times when the numbers 1, 3, 2, 2, and 3, 1 really all represent the same thing. And, one thing they represent is the sum is the same for all three numbers. So let's calculate a random variable based on that idea, that the sum of the numbers showing up on the dice. So over here I've constructed another table where instead of expressing what comes up on the face of the die, what I've done is say, okay, well, what is the sum? So this 2 right here is the sum of one die coming up 1 and the other die coming up 1. I add those two ones together, what do you know, I get a 2. So for example, this number 10 right here, I add the number 5 to the number 5, and yeah, I get a 10. But I also get a 10 when I add together the number 6 and 4, or the number 4 and 6. What I want to do is I want to create this random variable that says, well, what are the numbers I could possibly see? Well, there's going to be somewhere between 2 and 12, and we can see that in this table. All of our numbers are coming out somewhere between 2 and 12. What I'd like to do is count. I want to count the number of times each of these values for x shows up in this table. So I have constructed a method for finding out how many times. I have found the number 2 using this COUNTIF function. So the COUNTIF function says, where do you want me to look? And what do you want me to look for? So this is a concatenation. I'm combining two things, and I'm combining them into a sentence between quotation marks. Well, the sentence says, I want things to be equal to whatever is sitting in cell B11. Well, what's sitting in cell B11 is the number 2. So what it's doing is it's going to the table and saying, count up the number of times in the table that the number 2 shows up. And sure enough, it shows up just one time. Well, if I have my formula right, the number 3 seems to show up twice. So my f of 3 should say 2. And my f of 4, 1, 2, 3, should say 3. And so on. So here are my frequencies, and in fact this picture shows me what those frequencies look like. So this is the shape of my distribution. Now quite frequently I'm interested not necessarily in the absolute count here, but I actually want f of x to be a probability distribution. So I'm going to construct this, I'm going to change it to be a relative frequency. So I'm going to divide every number by the total number of objects in the table. Well, the total number of objects in that table is 36. So I could have divided by 36, but maybe I want to come back later and change this. And by the way, to make this more visible in the table, just for the picture's sake, I'm going to do a little bit more work. I'm going to ask Excel to round these numbers, and I'm going to have it keep just 3 numbers. That'll make it a little more visible in the picture what's going on. Okay, do my copying. All right, so here's the idea. I roll a die, and I count the number. I add together the numbers that show up on the faces, and look at this. I mean, the number 7 shows up with the highest frequency. I expect it to show up 0.167 times. What exactly is that 0.167? If you were to do a division, so that's equal to, there are 6 ways a 7 can show up. So 1, 2, 3, 4, 5, 6. And each of those ways has a probability of 1/36 of happening. So it's kind of like I'm adding up 1/36 6 times for this number that I was expecting, this 0.167. Okay, so I can take a sample space, decide what I want to do with it, and then construct a random variable that does what I want. Now, where did the probabilities for the random variable come from? The probabilities come back from the original probabilities in the sample space. So I didn't really make up any new probabilities. All I did is I went back and said, okay, tell me the probabilities up here in the sample space, and I will tell you how they translate into probabilities here with the random variable. All right, well, I wanted to do an experiment. So this distribution says this is what I should expect. Should I roll a dice and we roll it over and over and over again, I would start to see these frequencies. So what I did is I went to Excel and I said, well, why don't I test this out? So in Excel, what I did is I constructed an experiment where I'm rolling 2 dice with a random number generator, and that random number generator chooses a number between 0 and 6, and then it does that twice, and then I take the sum, and then I've repeated that 1,000 times. And from those 1,000 repetitions, I have created a probability distribution from the data itself. So over here, it's based on a thought process, kind of a mental gymnastics. Over here, I'm saying, okay, well, let's go test that out and see if it really happens. So I roll 1,000 dice, and I get this distribution. Notice that it's not exactly the same, but it's not that far off either. Well, let me rerun it. I reran it, and oh, look at that. The number 7 came up in my list 0.163 times, almost what I expected. Notice the number 4 came up a little bit more than I expected, 3 maybe a little bit less than I expected, 10 is almost exactly what I was expecting. Okay? Let's run this again and see if something else happens. Okay? Notice that as I continue to run and rerun this experiment, that my distribution from the actual data starts to take the form of my theoretical distribution on the previous page. It will never be perfect. It will sometimes be close, but it will never be perfect. So when somebody says to you, yeah, my dice are fair, that means that with enough repetitions, the distribution that we saw over here from the actual rolls should start to look like this theoretical distribution that came from you and I doing our thinking. So this is an example of how to take a sample space, think of something useful to do with that sample space, construct a random variable, and then from the sample space, construct a probability distribution over the random variable. I hope this helps. Thank you. I will see you later.